bed bugs, or cimicidae, are small parasitic insects. The term usually refers to species that prefer to feed on human blood. Early detection and treatment are critical to successful control. According to a survey, the most commonly infested places are the mattress, boxspring, as well as nearby carpets and baseboards. In fact, bed bugs thrive in areas where there is an adequate supply of available hosts, and plenty of cracks and harborages within 1.5 meters of the host. Because treatments are required in sleeping areas and other sensitive locations, methods other than chemical pesticides are in demand. Treatments can be costly, laborious, time-consuming, repetitive, may entail health risks, and cause embarrassment to the person affected. Public health: bed bug infestations spread easily in connecting units and have negative effects on psychological well-being and housing markets. In response, many areas have specific laws about responsibilities upon discovering a bed bug infestation, particularly in hotels and multi-family housing units, because an unprofessional level of response can have the effect of prolonging the invisible part of the infestation and spreading it to nearby units. Common laws include responsibilities such as the following: lessors must educate all lessees about bed bugs, lessee must immediately notify lessor in writing upon discovery of infestation, lessor must not intentionally lease infested unit, lessee must not intentionally introduce infested items, lessor must eradicate the infestation immediately every time it occurs at a professional level including all connecting units, and lessee must cooperate in the eradication process. An example of how epidemic bed bug infestation can become in densely populated areas is the bed bug registry. Mapped bed bug reports graphically illustrate how difficult it can be to eliminate bed bugs where many people live in adjacent units like in New York City, Los Angeles, and San Francisco. Pesticides: though commonly used, the pesticide approach often requires multiple visits and may not always be effective due to pesticide resistance and dispersal of the bed bugs. According to a 2005 survey, only 6.1% of companies claim to be able to eliminate bed bugs in a single visit, while 62.6% claim to be able to control a problem in 2-3 visits. Insecticide application may cause dispersal of bed bugs to neighboring areas of a structure, spreading the infestation. Furthermore, the problem of insecticide resistance in bed bug populations increases their opportunity to spread. Studies of bed bug populations across the United States indicate that resistance to pyrethroid insecticides, which are used in the majority of bed bugs cases, is widespread. Exterminators often require individuals to dispose of furniture and other infested materials. It is advisable to break or mark these infested items to prevent their being unintentionally recycled and furthering the spread of bed bugs. Effectiveness: the well-established resistance of bed bugs to DDT and pyrethroids has created a need for different and newer chemical approaches to the extermination of bed bugs. In 2008 a study was conducted on bed bug resistance to a variety of both old and new insecticides, with the following results, listed in order from most to least effective: ichelothrine, bifenthrin, carbaryl, imidacloprid, fipronil, permethrin, diazinon, spinosyn, diclovos, clofenop, and DDT. Note that the first of these, ichelothrine, is itself a pyrethroid-based insecticide in the past. However, it has been used principally for the treatment of cotton crops and so bed bugs have not developed a genetic resistance to it. Disadvantages: non-residue methods of mattress treatment are desired in place of contaminating mattresses with insecticides. Furthermore, other methods such as vacuuming must often be used in conjunction with pesticides to fully eradicate bed bugs. Spraying the mattress with insecticide is undesirable as the room must be suitably ventilated. Sufficient time must be given after application before the mattress can be used again and there is a risk of the user having an allergic reaction to the chemicals, not to mention other possible health risks including cancer and acute neurotoxicity. Concerns over the possible health effects of pesticides on people and pets, as well as the dispersal of bed bugs to neighboring dwellings due to repellent effects of insecticides, make the practice of chemically treating the mattresses problematic. Resistance: bed bugs are developing resistance to various pesticides including DDT and organophosphates. Some populations have developed a resistance to pyrethroid insecticides. Although now often ineffective, the resistance to pyrethroid allows for new chemicals that work in different ways to be investigated, so chemical management can continue to be one part in the resolving of bed bug infestations. There is growing interest in both synthetic pyrethroid and the pyrrole insecticide, clofenop. Insect growth regulators, such as hydroprine, are also sometimes used. Populations in Arkansas have been found to be highly resistant to DDT, with an LD50 of more than 100,000 ppm. DDT was seen to make bed bugs more active in studies conducted in Africa. Bed bug pesticide resistance appears to be increasing dramatically. Bed bug populations sampled across the U.S. showed a tolerance for pyrethroids several thousands of times greater than laboratory bed bugs. New York City bed bugs have been found to be 264 times more resistant to diltiazem than Florida bed bugs due to mutations and evolution. A population genetics study of bed bugs in the United States, Canada, and Australia using a mitochondrial DNA marker found high levels of genetic variation. This suggests the studied bed bug populations did not undergo a genetic bottleneck as one would expect from insecticide control during the 1940s and 1950s, but instead, that populations may have been maintained on other hosts such as birds and bats. In contrast to the high amount of genetic variation observed with a mitochondrial DNA marker, no genetic variation in a nuclear RNA marker was observed. This suggests increased gene flow of previously isolated bed bug populations, and given the absence of barriers to gene flow, the spread of insecticide resistance may be rapid. Physical isolation of humans is attempted with numerous devices and methods including zippered bed bug-proof mattress covers, bed leg moat devices, and other barriers. However, even with isolated beds, bed bug infestations persist if the bed itself is not free of bed bugs, or if it is reinfested, which could happen quite easily. Inorganic materials such as diatomaceous earth may be used in conjunction with other methods to manage a bed bug infestation, provided they are used in a dry environment. Upon contact with such dust-like materials, the insect's waxy outer layer of their exoskeletons is disrupted, which causes them to dehydrate. Although occasionally applied as a safe indoor pesticide treatment for other insects, boric acid is ineffectual against bed bugs because bed bugs do not groom. Organic materials, bean leaves. A traditional Balkan method of trapping bed bugs is to spread bean leaves in infested areas. The trichomes on the leaves trap the bugs by piercing the tarsi joints of the bed bug's arthropod legs. As a bug struggles to get free, it impales itself further on the bean leaf's trichomes. The bed bugs and leaves then can be collected and destroyed. Researchers are examining ways to reproduce this capability with artificial materials. Essential oils. Many claims have been made about essential oils killing bed bugs. However, they are unproven. The FTC is now filing a suit against companies making these claims. Contaminated belongings. Disposal of items from the contaminated area can reduce the population of bed bugs and unhatched eggs. Removal of items such as mattresses, box springs, couches etc. is costly and usually insufficient to eradicate infestation because of eggs and adults hiding in surrounding areas. If the entire infestation is not eliminated prior to bringing new or cleaned personal and household items back into a home, these items will likely become infested and require additional treatment. Treating clothing, shoes, linens, and other household items within the affected environment is difficult and frequently ineffective because of the difficulty of keeping cleaned items quarantined from infestation. Many bed bug exterminating specialists recommend removing personal and household items from the infested structure. Many metropolitan areas offer more effective treatments such as high heat dryers and dry cleaning with PERC with the added benefit of the treated items remaining stored until the affected home's bed bug infestation is eradicated. The improper disposal of infested furniture also facilitates the spread of bed bugs. Marking the discarded items as infested can help prevent infesting new areas. Items may also be sealed in plastic and stored until all eggs hatch and all larvae and adults have died. Bed bugs can go without feeding for 20 to 400 days, depending on temperature and humidity. Older stages of nymphs can survive longer without feeding than younger ones, and adults have survived without food for more than 400 days in the laboratory at low temperatures. Adults may live up to 1 year or more, and there can be up to 4 successive generations per year. Vacuuming. Vacuuming helps with reducing bed bug infestations, but does not eliminate bed bugs hidden inside of materials. Also, unless the contents of the vacuum are emptied immediately after each use, bed bugs may crawl out through the vacuum's hoses and re-establish themselves. Heat treatment. Steam. Steam treatment can effectively kill all stages of bed bugs. To be effective, steam treatment must reach 150°-170 degrees Fahrenheit for a sustained period. Unfortunately, bed bugs hide in a diversity of places, making steam treatment very tedious, labor-intensive and time-consuming. There is also the risk of the steam not penetrating materials enough to kill hidden bed bugs. The steam may also damage materials such as varnished wood, or cause mold from the moisture left behind. Effective treatment requires repeated and very thorough steaming of the mattress, box spring, bed frame, bed covers, pillows, not to mention other materials and objects within the infested room, such as carpets and curtains. Clothes dryers. Clothes dryers can be used for killing bed bugs in clothing and blankets. Infested clothes and bedding is first washed in hot water with laundry detergent, then placed in the dryer for at least 20 minutes at high heat. However, this does not eliminate bed bugs in the mattress, bed frame and surrounding environment. Sterilized fabrics from the dryer are thus easily reinfested. Continually treating materials in this fashion is labor-intensive, and in itself does not eliminate the infestation. Hot boxes. Placing belongings in a hot box, a device that provides sustained heat at temperatures that kills bed bugs, larvae, and eggs, but that does not damage clothing, is an option. Pest control companies often rent the devices at nominal cost, and it may make sense for frequent travelers to invest in one. Building heat treatment. This method of bed bug control involves raising room temperatures to or above the killing temperature for bed bugs, which is around 45 degrees Celsius. Heat treatments are generally carried out by professionals, and may be performed in a single area or an entire building. Heat treatment is generally considered to be the best method of eradication because it is capable of destroying an entire infestation with a single treatment. For safety reasons, it is important that HEPA air filtration is used by your professional during any heat treatment to capture particulate and biological matter that may be aerosolized during the heating process. Freezing. Bed bugs can be killed by a direct 1-hour exposure to temperatures of -16 degrees Celsius. However, bed bugs have the capacity for rapid cold hardening, that is a 1H exposure to 0 degrees Celsius improved their subsequent tolerance of -14 and -16 degrees Celsius, so this may need to be maintained for longer. Freezer temperatures at or below -16 degrees Celsius should be sufficient to eliminate bed bugs and can be used to decontaminate household objects. This temperature range should be effective at killing eggs as well as all stages of bugs. Higher temperatures, however, are not effective, and survival is estimated for temperatures above -12 degrees Celsius even after 1 WK of continuous exposure. For household use, it is important to confirm that the temperature range of your freezer is capable and configured to maintain cold below -16 degrees Celsius, however home freezers should be capable of maintaining this temperature. Fungus. Preliminary research has shown the fungus Beauveria bassiana, which has been used for years as an outdoor organic pesticide, is also highly effective at eliminating bed bugs exposed to cotton fabric sprayed with fungus spores. It is also effective against bed bug colonies due to the spores carried by infected bugs back to their harborages. Unlike typical insecticides, exposure to the fungus does not kill instantly, but all subjects died within 5 days of exposure. Some people, especially those with compromised immune systems, may react negatively to the concentrated presence of the fungus directly following an application. Drugs. Early research shows that the common drug taken to get rid of parasitic worms, ivermectin, also kills bed bugs when taken by humans at normal doses. The drug enters the human bloodstream, and if the bedbugs bite during that time, the bedbug will die in a few days. Stramectal is also effective against mosquitoes, which can be useful controlling malaria. References. External links: NPMA bedbug fact sheet.